Welcome to exam days. This is the Electromagnetic Theory and we are here for Fresnel Law. Now for this we already see that there is a oblique incidence. For oblique incidence, there are certain cases. We will see that we will observe these certain cases. So for case 1, what we will see? Case 1. In this, the condition is that polarization of incident wave, polarization of incident wave is parallel to plane of incidence. Okay, means polarization is parallel to the plane of incidence in simple words. For this, if you see the magnetic field, it is outside everywhere. So magnetic field is outside everywhere. Clear? And electric field is perpendicular. Electric field is in this direction. Clear? Like this. Electric field is in this direction. Also with this. Same things. Now what we will see some boundary conditions. Boundary condition for this case. For this case, first boundary condition is that tangential component, it is perpendicular, tangential component of E is continuous. Okay, continuous across boundary. And another condition is that tangential component of B, that is also continuous. Both are continuous. This is the boundary condition. If these are the boundary conditions, then we will apply it for R and I and T. Just simply expand this. So it's going to be, for example, I already told you that this is what EI, this is ER, this is ET, this is BR, this is BI, this is PT. Fine. So EI, if we take the cos theta angle minus ER cos theta R must be equals to ET cos theta. This is the condition. It's after boundary condition. Now for the B1, if you see BI, BR, BT, all are in the same phase. So it's going to be H of I plus H of R must be H of T. And H of I can write this as BI by mu, or if you want to write it as N1, you can write this. And BR also by mu. This is mu1. Clear? Which is equals to BT of mu2. This is what we have. Also we know the famous equation, that is E is equals to B. Clear? And if I do so, then we have two cases, that E1 must be equals to B1 and E2 must be equals to B2. So if I do this, I simply got the, in terms of E, this is EI plus ER must be equals to mu1 B1 over mu2 B2 P2 into PT. This is what we have. Clear? So we have most two equations. That is, this one is the first equation, this is the second equation. Just solve this and you will get the results. That is in terms of this ratio of E R by ET, ER by EI and ET by EI. For incident, we have condition for theta I equals to theta R for angle of for law of reflection, and in such a way that EI cos theta I plus, better minus it's okay, minus E R cos theta R, but theta R and theta I are same here, which is equals to ET cos theta T. Clear? Also EI plus ER, or better to say that, okay, EI plus ER here is EI plus minus ER is going to be cos theta T over cos theta I ET. Also EI plus ER is mu1 or mu1 B1 over mu2 B2 ET. Now solve these 1 and 2. For this, add 1 and 2. Okay, add 1 and 2 here. What you will see that 2i, 2ei is equals to, now let's, before that, let's make it more easy, that let alpha is equals to cos theta T over cos theta I, and beta is equals to mu1 B1 over mu2 B2. So by using this equation, 1 become EI minus ER equals to beta ET. Fine. And this equation 2 becomes EI plus ER equals to alpha ET. Now just mark them 1 and 2 again. Just add them. Add 1 and 2. What we got is 2 EI is equals to, it's alpha plus beta ET, isn't it? So from here, ET is equals to 2 over alpha by beta, alpha plus beta into EI. This is the equation.